Neil from Messick's here to talk to you about these glossy tractor brochures. When you flip through the inside of these things and get around to the back where the important information is, right? The numbers that tell you what this machine is really capable of doing. There's a lot of confusing numbers back here, and there's also a lot of ways for tractor companies to manipulate the numbers that are on the back of these spec sheets to make their machine look like something that it may not be. So we're going to talk about these figures today. Nothing about Kubotas in particular. This is going to apply to all tractors from all makes of all sizes, but we're going to work through a couple of these brochures and help you have a better understanding of what a lot of these numbers actually are telling you.
Messick's, a helping hand with your land.
We're going to start up here at the front at the tractor's loader, and for good reason. There are so many measurements that can be taken on your loader in order to manipulate what its capacity appears to be. Even within Kubota's own equipment line, if we look here at this LX series loader, they give you about 8 or 10 different measurements for this loader. But if we jump over into the Grand L series brochure, you've got as many as 15 and 18 things that are on that brochure, right? So there's a lot of numbers, a lot of specifications, and a lot of places to get confused and deceived. The first thing that you're going to want to look at when you look at any of these measurements is where are they being taken, and are they telling you where they're being taken? Many times measurements for a loader are rated back here at the pivot pin. Okay, that's going to be right here where this loader arm comes out and this pin attaches onto the bucket. And when you look through here at things like maximum lift height, lift capacity, breakout force, those three numbers here on the Kubota sheet are given at two different places, both here at the pivot pin and also 19.7 inches forward, or what we would call bucket center. Now, on this tractor with a fairly small bucket, 19 inches forward puts you about 2/3 of the way out on the bucket. It's not even actually the center of the bucket, but this matters a lot. As your load and as your measurement comes away from the tractor, these numbers start to look a lot worse. So if you want to make your tractor look extremely capable, you take all of your measurements back here at the pivot pin. But you probably can figure out you don't lift things here, right? All of your material, all of your dirt, anything sitting on your pallet forks is all well out in front of this measurement point. So it's very common for us to see people come in owning tractors from some lesser known brand names, expecting them to lift huge amounts of weight when in reality they don't. The issue is often that people don't understand how to read this spec sheet. If a spec sheet does not call out exactly where that measurement is taken, if it doesn't say at bucket center or at pivot pin, more often than not, you're probably looking at that higher pivot pin measurement. So we've covered lift capacity, but next up is breakout force. Now, breakout force is this bucket's ability to roll itself backwards. And that, like the lift capacity, can be measured either at bucket center or back at the pivot pin. Now, I'm gonna rely more on bucket center measurements for all of these things because they give a much more realistic view of what that's going to do. But rollback actually matters a lot more than what you might think. When you push that bucket into a pile of dirt and you need to roll it back and fill it, a greater breakout force number is going to make it easier to fill that bucket. But it also is really helpful when it comes to lift and carry applications. If you take pallet forks on your tractor and you push your forks into a pallet and you just need to get it up off the ground so that you can drive it around, oftentimes your much higher breakout force number allows you to be able to curl that pallet back just enough to be able to drive and move it around. So even though you might have 1,000 pounds of capacity at your loader, if you've got 1,500 pounds of rollback, oftentimes you can get that 1,500 pound load up enough that you're able to move it around. Next up is lift height, and lift height's a really important number because it's got implications on a lot of different things. When you look at the lift height number itself, it most often is going to be measured up here at this pivot pin, right? But if you look here at my bucket is below where that pin is at, and getting an accurate lift height measurement on your tractor can be challenging because you can have variations in whether your bucket is pinned on, whether it's on a skid steer coupler, so there's changes here. Now this is going to matter a lot to people who are running construction equipment because they need to know whether they can say like clear the side of a truck or clear the side of a dumpster. So when you get up to more construction oriented machines, sometimes you'll get height specifications that are taken from the bottom of the standard equipment and bucket, or even from the bottom of the tip of the bucket with the bucket rolled over in some cases. So you're going to want to watch, but oftentimes know the most common one to see is up here at the pivot pin, and that's often not going to be a true height measurement. Another game that tractor companies can play is manipulating the rest of their lift capacity specifications by manipulating their height. The more lift height your tractor has, the more it decreases its lift capacity. This loader moves in an arc when it goes up and down, and its point of the least capacity is out here in the arc when the loader is lifting, pointing out away from the tractor. Now, if your loader is longer and you're further away from your tractor and you have more lift height, it hurts your lift capacity specification. If Kubota suddenly wanted to have a 20% bump in this tractor's lift capacity, they very simply could do that by limiting the height that the loader can lift up to, maybe putting shorter cylinders and stuff in there and not lifting as high. So keep that in mind. A tractor that has a high lift height often can have a higher lift capacity than what it might look like on paper down at these lower carrying heights. Next up are the loader's cycle times. When we work through the spec sheet here, you're gonna see 4 different numbers that are gonna tell you the number of seconds that it takes for certain actions on that loader to happen. That's gonna be important when it comes to your productivity. If you're gonna be doing a lot of, say, in and out of a dirt pile, the time that it takes that loader to lift up and raise and for that bucket to roll out is a significant impact on your productivity. So tractors that are gonna have faster cycle times overall can be more productive machines. Another major impact on your productivity is how full you can get this bucket full of dirt or material or stone. And that comes out in 2 different areas on this spec sheet. The maximum rollback angle is going to tell you how far back you can roll that bucket. And the further back you can roll it, the more you can get the material heaped up here on the top and get that bucket good and full. You're going to notice some tractors having 4-bar linkages on them. That's put there in order to manipulate those rollback angles and give it a little bit more range of motion. You can also change this stuff depending on where you're going to pin your hydraulic cylinders down there onto the end. This impacts the breakout force that we were talking about before. If you have a really high breakout force because you've pinned your cylinder up towards the top of your bucket, you're going to have a much lower rollback angle then, impacting your ability to fill the bucket, right? So there's give and take between all of these things. You'll also notice a number on the Kubota spec sheet here about struct or heaped capacity of this bucket. A struct capacity is taking the bucket here and going straight across here and not lumping the material up here on the top. A heaped capacity is going to be a larger number, but it's going to be assuming that you've got some amount of mounded material up here on the top. Now that's usually only applicable to things like mulch, where you can easily kind of heap that extra material up there on the top. So your struct capacity is going to be the more honest of those 2 numbers. The next up is the relief pressure on the loader. As you're working this valve around, it's feeding hydraulic pressure into the valve, into your cylinders, but there's a relief valve in there that once the system has come up to pressure, it allows that excess hydraulic fluid to run off and back into the tank again. It's pretty unusual to see this specification for OEM loaders. Kubota does give it on some of these, not all of them. But it's very, very applicable when it comes into looking at aftermarket loaders. If you go pull a loader from a company like Ansung, Woods has gotten out of the loader business now. I think Allo still makes some. Oftentimes those loaders are gonna have what looks like really good specifications. And if you read through their spec sheets, you're gonna find at the bottom, oftentimes they're gonna tell you the pressure that specification was taken at, right? Now that pressure is gonna impact lift capacity, rollback, right? All the power of the cylinders are driven by that pressure. But in those aftermarket loaders, they don't know what tractor that loader is going to go on. And the tractor's hydraulic system often is producing a pressure that is below the point of what that loader's pressure is set at. So when you look here at my Kubota specification sheet, they're running their relief at 2,500, 2,600 PSI. Oftentimes aftermarket loaders will be rated at 3,000 PSI. 20% or so difference that you could have in that lift capacity number that's not actually there because you're not feeding that higher pressure into your loader to hit those numbers. So watch that. Pretty unusual when you're dealing with all OEM equipment, but when the loader is being sourced from an outside company or it's some kind of aftermarket loader, you might end up with a mismatch that impacts your specifications. Too often when we go through here and we get people that hyper focus on all these numbers that I'm filling out, right? The guys that come walking in here with clipboards a lot of the time, wanting to know every little detail about these things so they can compare one to the next. They totally end up overlooking the feel of the machine. And there's nothing in these glossy brochures or on these spec sheets they're going to be able to tell you how a loader or a tractor feels in operation. And there is no substitute for getting on a machine and working its hydraulics and feeling it for yourself. The biggest thing here that I will notice on loaders is the ability for a loader to do multiple functions at one time. For that boom to lift and the bucket to curl simultaneously takes an art from the tractor manufacturer to be able to balance the flows of those machines. Ultimately, these are simple hydraulic systems, and that oil goes the path of least resistance, and less sophisticated manufacturers or companies that don't build their own attachments, which is most, have a much harder time getting the balance right between that loader and bucket and getting things to work smoothly together. So don't overlook all of this. While we go through and there's value in what all these numbers are telling you, you will never get a sense for how a tractor feels and operates without actually getting in its seat. Next up here, we're going to move on to the tractor, and the very first thing that every one of us is pre-programmed to look at is the engine, right? And in most cases, we overestimate the importance of engine horsepower. When we look at the rest of this machine, things like its weight, its hydraulic capacity, the type of transmission that it has a lot more bearing on the work that it can do than the simple amount of horsepower that's down here under the hood. But it is still relevant, right? Horsepower is a really tricky thing because it too, like most of the rest of the tractor, can be measured in a number of different ways. On the better ones here, you're going to get 3 different horsepower numbers for that engine: gross, net, and PTO. The highest horsepower number is going to be the gross horsepower, and that's the power that the engine can produce with no exhaust and no air cleaner attached to the engine. It also goes by a standard called SAE J1995. Very often on some off-brand machines, you'll see only horsepower listed, but if you look down there in the footnotes at the bottom, you'll see the SAE standard that they use to measure it. Most often, that's going to be the gross horsepower number. Now, we all know you don't run your tractor with no muffler and no air cleaner, right? So the more honest of those numbers is going to be the engine net power. That's going to be the ones with that stuff actually attached. It is a much better reflection of what the engine produces. However, in tractor applications, there's a better number still that we can look to, and that's the PTO horsepower. The PTO horsepower is the amount of power that that engine is actually able to put out the PTO to the back of the machine. And very often it's also telling you the amount of power that's making it through to the transmission of the machine. It's going to give you drive power. You're going to have parasitic losses in there from all kinds of places in the machine, including like the hydraulic pump and stuff that's there. But it is, PTO horsepower is kind of the great equalizer of all of this stuff, and it's probably the most important horsepower number on your tractor, as it tells you the power that's actually available to go out and do work for a lot of your implements. You can notice huge variations between manufacturers between that net and PTO horsepower number. Some well-engineered, very efficient machines can lose as little as 10% between the engine and the working parts of the machine, where you're going to find some others that can be upwards of 20 to 25%. Excess engine horsepower, if you got a tractor that's got a big engine horsepower number or a huge gross horsepower number, isn't doing you a whole lot of good. You'll always want to go and compare machine to machine using PTO horsepower. Now, Kubota, being an engine company, tends to give an excess of additional information on specifications of the engine, and some of these have relevance and some of them don't. If we look at, say, the number of cylinders and the aspiration of the engine, the number of cylinders may or may not matter. Oftentimes, higher cylinder counts can run a little smoother than others, but then some configurations are balanced and some aren't. I can't say going from one machine to the next I've ever noticed huge reason to have one cylinder count or another. Aspiration can be important. Naturally aspirated engines do lose horsepower as they go up to elevation, and turbochargers can give a lot more power to the engine in a small engine block, but do bring along some additional mechanical complexity, so it's good to know those things. But I do like watching the total displacement number. The number of CC of the engine, the displacement of those cylinders, I think has become really relevant in 26 horsepower tractors. 26 horsepower is the limit that once you go above that, you're gonna pick up exhaust treatments, diesel particulate filters and stuff on top of that engine to scrub the exhaust. And so for that reason, there are many tractor options right at 26 horsepower. But not all of those 26 horsepowers are also the same block. In many cases, larger blocks are being detuned a little bit down to that 26 horsepower mark, and you'll see some really large capacity, high displacement 26 horse engines in machines like the Standard L and the LX that can really punch above their weight class because of the amount of torque that comes from those higher displacements. It's not typical to see torque curves on any of these spec sheets, which I think is unfortunate. That would help give that explanation a little bit more, but you can kind of look at the displacement and oftentimes infer what you're probably going to find there. Other stuff that's often on here too would be rated speed, how fast that engine is spinning in order to reach its horsepower number. Lower rated speeds often are quieter engines in operation. We used to pay attention to things like the alternator and the charging amps, but with the advent now of LED work lights and stuff, that's become less important now. So that picks up a majority of the things that you're gonna find about the engine in your tractor. Working down our spec sheet here, we get to the next section on the PTO and the drivetrain. Now, PTOs are industry standard for the most part, right? You're gonna find either 540 PTOs or 1000 RPM PTOs. You won't pick up 1000 RPM PTOs till you get over 100 horsepower up in ag and utility oriented tractors. All small machines are going to use an industry standard 540 RPM PTO that's compatible with all the implements that you've seen out there on the market for tractors, so lots of variety. There often is not information about the 3-point hitch that your implements are going to attach to, and this is something you're going to want to pay attention to if you're shopping for a tractor, because convenience features back here like extendable ball ends and ratcheting adjustments and pinning sway bars make the 3-point hitch a lot nicer to work with. You won't find that information here. If we move forward into the rest of the tractor, on the other side here of the PTO is the tractor's drivetrain, right? The bits that are actually driving the wheels. Now, many machines are gonna have hydrostatic transmissions like this one does. You're gonna wanna pay attention to the number of ranges that hydrostatic has. 3 is better than 2. You're also going to find tractors that are going to be gear drive transmissions, and sometimes you're going to find references on here to the type of clutch that's on that gear driven transmission. Hydraulic clutches or some kind of dual clutch system is much better than some of the older dry clutch or unsynchronized gear transmissions that you'll find on some real economy oriented tractors. Wet clutches, hydraulic clutches can be a lot nicer to drive, and the clutch plates tend to hold up a lot better too. Don't go buy a geared transmission assuming that it's going to be more reliable or less expensive any more than what a hydrostatic is. Modern hydrostatic transmissions are generally more reliable and not more costly anymore like they used to be. They are still less efficient. They will put power to the ground not as well as what gears do, but a lot of those older notions that might have driven people away from hydrostatics today are no longer true. Next up is the tractor's hydraulic system, and there's points here that I think are important and often misrepresented. Your tractor's hydraulic system is important, right? You've got a pump that sits down at the bottom of the tractor that's pumping that fluid out to your loader, to your implements. It's a way of transferring power, right? And more GPM is more better, right? It's moving more horsepower out of that hydraulic system and out into that implement. Oftentimes when you look at this spec sheet, you'll see something called total pump flow called out on the spec sheet. But know that your tractor has not one hydraulic pump, but actually 2. There's also a hydraulic pump that's on there for your power steering. And that pump is simply pumping that hydraulic fluid that is steering your front wheels. It's not available to those implements at all. It's become very common today for companies to sum these 2 pumps, both your implement pump and your power steering pump, into a single total hydraulic flow number on their spec sheet. And while it makes a nice big number, the flow of your power steering has nothing to do with the flow that's coming out to your implements, right? So question with a skeptical eye anytime that you see just a total hydraulic flow number on the spec sheet. And if you're going to be trying to run something like a Lane Shark, for example, that needs as many gallons per minute as what you could possibly deliver out to it, know that if you have a single total flow number on here, that's probably not what's going to make it out to your implement. Next up are the machine's physical dimensions, and you would think that if anything here could be cut and dry, it should be like, how wide is the thing, or how tall is it, or what's it weigh? And even these are not so easy. When we go through and we look at things like the length, the width, the height of the machine, you need to pay attention to whether the spec sheet is calling out the tires that are fit on the machine when those specifications that are taken. Many times we're gonna have anywhere from 4 to 15 different tire options for a tractor, and those tire options often impact these measurements. The one you're gonna wanna pay specific attention to is the height of the roll bar. Many times people are gonna watch that because they want to pull their tractor into a garage, and as large as these machines are, an inch or two can have a big impact on whether that roll bar is gonna clear your garage door or not. But there are different sizes of tires on these machines. Now, most of the time, these are taken with like a standard industrial tire because that's what ends up on about 80% of our small tractors. But there are some machines that periodically will use an ag tractor tire that sometimes might be a little bit higher and a little bit more narrow than what the R4 sometimes are. So pay attention to that. A lot of times, if I've got a customer who needs to know an exact measurement for that garage door purpose, I'm gonna try to find the actual tractor on the actual tires and walk out with my own tape measure because these numbers can be so inaccurate. Another thing you're going to want to watch would be the tractor's weight. Weight is something that people tend to really focus on because it impacts the tractor's traction and its stability and its ability to lift a heavy load with that loader and balance everything out. These weights, though, sometimes aren't operating weights. Oftentimes they're shipping weights. I've seen cases before where the weight may not even include tires because the manufacturer has pulled the number off of their tractor when it's arrived here in a crate from somewhere, right? So you go through and you add sometimes tires, fluids, an operator on the seat. These weights often are low, especially if you're looking at things like trailering a tractor. I would add a good 10% buffer or so onto here because more often than not, machines actually end up being heavier than what they're pointed out as being on the spec sheet. So there's no substitution for, unfortunately, scales or a little bit of detective work in order to figure out what a machine actually weighs. Just like there's a lot of moving parts on our loader, there's a lot of moving parts on your backhoe as well. And understanding how everything moves and manipulates back here can help you understand these numbers a lot better. There's 3 major numbers that you're gonna look at on any kind of backhoe. It's gonna be the dipper stick, digging force, the bucket digging force, and the digging depth. So the dipper stick force is the force of this dipper here to pull that bucket back into the machine. Being able to pull that straight back in helps you cut as you go and dig a flat bottom in the bottom of your trench. The next one is your bucket breakout force. That's going to be how hard this cylinder can manipulate this bucket to bring that bucket around, and it really helps to dig out hard soils. Now, as you get into more construction-oriented backhoes like this B26, sometimes you'll see quick couplers that can be put in these bucket systems. If you have a quick coupler in here, some quick coupler systems, not Kubota's, will impact the bucket breakout force in a really negative way, so pay attention to that. The next thing that you often don't know would be your dig depth, unfortunately. Every backhoe is going to come through with some kind of expected dig depth, and those are usually measured with what's called a 2-foot flat bottom. So that backhoe is going to dig in a curve as it goes back and forth. The bottom of that curve, the 2-foot flat bottom, is that flat section that allows you to reach that maximum depth. Now, if you needed to dig at that maximum depth, you're going to have to reposition the machine every 2 feet. In order to reach that. So that's not an efficient way to dig, right? You always want to spec a backhoe that goes well beyond the maximum dig depth that you expect to work at to be able to not position every 2 feet as you go. It'd be a really long day that way. But even then, with that 2-foot flat bottom, oftentimes manufacturers of backhoes don't know what machine they're going to go onto. It's very unusual for these tractor companies to make their own attachments in the way that Kubota does. And oftentimes they're relying upon the specification sheet from the company that built the backhoe and not taking into account the intricacies of the tractor that the backhoe is going on. Kubota's BH77, for example, can be used on an LX, a Standard L, or a Grand L series tractor. And when I look at my 2 specification sheets right here, Kubota's good enough to give us one set of specifications when that backhoe is put on an LX and a different set of specifications when it goes onto a Grand L, right? Because when the backhoe is put on the back of that machine, it may be high or low sitting on the back of the tractor. It might be close to the machine, it might hang far behind it. It all depends upon the mounting kit that's used to put that backhoe onto the back of the machine. So pay attention to that. If the company is good enough to go out and call out the model number that the specifications are coming from, you know that you probably have some truthful numbers. But in the absence of that, be a little cautious when it comes to that total dig depth or things like departure angles, because you just don't have all the information that's needed in order to rely upon the spec sheet. So that's a little bit of info on what's on the back of these glossy brochures. If you learned anything here, hopefully it's that you need to look at this stuff with a little bit of skepticism. I'm not pointing out anything here that I'm seeing Kubota doing, but as I've been selling tractors for the last 20 years and you continue to have new companies enter this market that have something to prove, I see more and more cases anymore where the best case scenario is put on the back of these things. You know, today we see a lot of tractors that are measured at the pivot pin at a carrying height, which can nearly double the capacity of your loader. Great numbers for marketing. Bad numbers for you to rely on if you have a task to do that relies upon the things that you read back here. So don't try to interpret these things on your own. If you're shopping for a tractor and you have a task or an implement in mind that relies upon you hitting a very specific number, make sure you have a conversation with your salesperson and that they understand your needs appropriately so that we can put you into the right machine. It's what we do here. So if you're shopping for a piece of equipment and we can help, or if you got parts and service needs for a machine you've already got, give us a call at Messick's. We're available at 800-222-3373 or online at Messicks.com. Function kit's out on the loader. It's a transfer. Okay. I see you laughing.